Hi everybody, welcome to lecture number 1, Introduction to Data Communication and Networks. In this lecture, we are going to discuss about the basic concepts of data communication and networks, and also we are going to see what are the various communication components, the components of a communication system, network criteria, categories of networks, standards and standards organization. So these are the topics we are going to cover in this lecture. Let's start. Data communication. Data communication and networking have changed the way we do business and the way we live. So completely everything is changed. So without data communication and networking, there is no life at all. So we are using the data communication and networking everywhere. So even for the education system, banking system, healthcare sector, in so many sectors, so many domains, in all the domains, almost in all the domains. So we are using the data communication and networking. People have found how to communicate with others, with other people in the world, to express their social and other opinions and the problems. So there are so many social medias available nowadays. So we can easily express our opinions, our suggestions, our problems. So everything we can share. So all these are happen because of data communication and networking. So communities in the world, they are not isolated anymore. So there are so many applications nowadays available, data communication and networking based applications. So we can use the applications and we can communicate with anybody in this world. So you no need to be physically there. You can communicate with anyone from any part of this world. So data communication and networking. So the main objective of this is communication. So sharing the information. Sharing can be local or remote. So local, so you can understand the word local or remote. So we can share the data within a network, or we can share the data from one network to another network. So globally, anywhere we can share the data very easily by using the data communication and networking. So here, the word data is going to be a very important one. So what is data? Means, so it could be anything. So it could be a message, a file, a document, a audio, a video. So it could be anything. So this data easily you can transfer from one place to another place. That means you can exchange the data between two devices by using some transmission media. So in the later on, that means in the lecture number 3 and 4, okay, we are going to discuss about this transmission medias. What are the transmission media available? What are the types available? So the properties of all the transmission media we are going to discuss. So data communication means exchanging of data between two devices from one device to another device. It could be local or it could be remote. So anyway. So the effective of data communication system, it depends on the delivery, accuracy, timeliness, and jitter. So these are all the technical words. So you may not understand in the first slide itself. So in later on, okay, that means in slide lecture number 10 or 11. So we are going to discuss about so many parameters. Okay, that means how you can measure the performance of a network. So there are a lot of parameters available. So we will discuss that. So here, so just in abstract way, delivery, accuracy, timeliness, and jitter. So these are all the ways how you can measure the effectiveness of your communication system. Now, the second topic here is data communication system components. So what are the various components of a data communication system? So this is a data communication system. So here we can see the first very important component is the sender. So sender is going to send the data or a message or any form of data to a receiver. So we can send it either locally or globally. So sender is the component one. The first component is the sender. Then the second component is the receiver. Receiver is the person, or we can say as a machine or a host, whatever it could be. So it's going to receive the data from someone. So the receiver is the second component. The third very important component is the media. That means the medium, or we can say it is a cable. So which is going to connect the sender and the receiver. So medium could be like wired or wireless also. So we will discuss it later in lecture number 6, 7 like that. So what are the different types of medium available? Okay, so wired and wireless. So using any medium, you can send the data to the receiver. So the third very important component is the medium. Then the fourth component is the message. So message is the data that you are going to send. So it could be a text data or a email, okay, or a picture, okay, or a video, audio file. So it could be anything. So the message is the fourth component. Then the very important component is protocol. So protocol means it's a set of rules. Okay, you can see step 1, step 2, step 3. There are some set of rules. Both the parties, that means both the sender and the receiver, going to accept it. So they have to accept it and they have to follow that rules. Okay, so a set of rules, it is called the protocol. So this is the fifth component, component number 5. So we can see the explanation in the next slide. So message. So message means it could be an information or it could be a data to be communicated. So the popular forms of information are text data, numbers, pictures, audio, video. So these are all different forms of messages. So sender is a device or a host which is going to generate, which is going to originate, okay, generate the data, the message. So the sender could be a computer or it could be a workstation or a telephone handset, video camera, so whatever it is. So these are all different devices. So generally we used to call it a host. Then receiver. So receiver is a device in the network which is going to receive the message, which receives the data. So it could be a computer, okay, or a workstation or a telephone handset, okay, that means your mobile phone. So television, it could be anything. So the receiver is a device which is going to receive the data from the sender. Then transmission media. So transmission media is a physical path which is going to connect the sender and the receiver. So all the data, whatever the data exchanged between the sender and the receiver, so it will be traveling, okay, it will be traveling in the transmission media only. So there are different types of transmission media available. So broadly we can classify the transmission media into wired and wireless. So if you see, if you take the wired, okay, these are all the examples. So we will discuss it as a separate lecture. Twisted pair wires, coaxial cable, fiber optic cables, and radio waves. So here you can see the radio waves. So radio waves are going to be wireless communication. The remaining thing, twisted pair, coaxial, fiber optic. So these are all the wired, okay, wired connections. The last one is a protocol. The fifth component is a protocol. So a protocol is a set of rules. So that is going to govern the data communication. It's going to manage the data communication. So without protocol, there is no network in this world. Okay, there is no data communication in this world. So protocol is going to define some set of rules. Both the sender and the receiver, they are going to accept it and they are going to follow it. Then, so protocol represents an agreement. It is an agreement between the two parties, okay, or communicating devices. So the two parties here, sender and the receiver. So these are all the 5 different components of a communication system. So the next topic is data representation. So there are different types of data you can send it nowadays. Okay, so text data, numbers, images, audio, video. So the best example is, okay, the very popular application app we are using nowadays. It is a WhatsApp. So if you take in WhatsApp application app, you can send any type of data. Okay, you can send the text data, you can send the numbers, images, audio, video. So any type of data we can share by using the WhatsApp application. So what is a text data? So we already know this. Okay, it's going to be like ABC. Okay, that means the alphabets. And then it's going to be your computer. You understand. The computer may not understand these ABCs. That means the alphabets. So it will be converted into bits. So if you want to convert into bit, you have to follow the ASCII. Okay, American Standard Code for Information Interchange. So you have to use the ASCII format. Then automatically your alphabets will be converted into zeros and ones. You can send the numbers also. So the numbers also, okay, your system is not going to understand. If I just give 2, for example. So if I give 2 means your system is not understanding what is 2, okay, because your computer can understand only zeros and ones. So this should be converted into a binary one. So the result will be, it will be in the form of bits, okay. So directly converted to the binary numbers. Then, so images. So usually if you talk about the images, the very important word is the pixels. So it's a composed of matrix of pixels. So what is a pixel means? It's a small dot, a single dot. Okay, that is called the pixels. So audio recording. So that means it's a recording or a broadcast of sound. So audio means it's going to be the sound or music, and video, it's a picture plus you will have the sound also in that. So these are all the types of data we can share. Okay, we can send from a sender to the receiver by using a communication system. So you can send text, numbers, images, audio, and video. So the next topic is data flow. So generally, there are three different types of data flow. Okay, we can say it's a mode of transmission. So the first one is called the simplex, a simplex transmission. Second one is a half duplex transmission. The third one is the full duplex. So if you take your mobile phone, okay, your mobile phone is a full duplex device. So that means you can send and receive the data at the same time. So you can hear somebody, okay, somebody is talking to you, you can hear that, and at the same time you can talk. So you can send the data and you can receive the data at the same time. So that is the full duplex devices. So there are some devices which are off duplex also. Okay, we are going to see the examples in the coming slides. So in a half duplex device means either you can send the data, okay, or you can receive the data, okay, in different times. You cannot do this both at the same time. Okay, so direction of the data at time 1, direction of the data at time 2. So you cannot do both at the same time. Okay, so if you are sending the data, you cannot receive the data. If you are receiving the data, you cannot send the data. So you can do any, that means sending the data or receiving one at a time. Okay, but here we can do it simultaneously. Then the third one is the simplex. Okay, the simplex mode. What is the simplex mode means? It's just going to be like one way. So if you're watching this video in a YouTube, okay, so that is going to be a simplex form. So from the YouTube to you, it's going to be a one-way communication. So it's like the direction is only one way. You cannot do both. Okay, so this is going to be the simplex form. So there are three different modes of communication: simplex, half duplex, and full duplex. So we can see the examples also in the coming slides. So simplex means, so it's going to be unidirectional. Only one of the two devices on the link can transmit the data. So one is going to be the sender, the other one is going to be the receiver. So one is going to send that means transmit the data, the other one is going to receive the data. Here, the channel, that means the link, okay, the capacity of the channel will be completely utilized only for sending the data. Only for one direction, the channel will be completely utilized. The best example is a keyboard. So keyboards, so that means from the keyboard to system to the PC, so only the data will be like it should be, it's a unidirectional. So if you can type some words in a keyboard, so it's going to reach your system. So always it is going to be a unidirectional one. Then the traditional monitors, okay, not the touchscreen monitors. The traditional monitors also example for the simplex. Okay, so just you can see the output. That's it. You cannot give any input. But nowadays we are having that touchscreen monitors. So touchscreen monitors, or it is going to be the full duplex. Now the next one, the second one is a off duplex mode. So here both the stations, that means the sender and the receiver, they can transmit, okay, transmit and receive, but not at the same time. So if you are sending the data, you cannot receive the data. If you are receiving the data, you cannot send the data. So the entire capacity of the channel is taken over whichever of the two devices in transmitting at a time. So if a sender is using the cable, that means if somebody is sending a data, means the capacity of the entire transmission media will be used only for sending. Okay, so this is a thing. Now you can see the examples. Walkie-talkies. Walkie-talkies are very popular in police departments. Okay, so in the police departments, the policemen, okay, they will be having the devices walkie-talkie. Still, it is available, so they can use it only for sending. Okay, they will send the data. For example, I'll just say, so they'll say hello, then they will say over. So after that word over, the other person, that means the person who is in the other end, okay, he will start his conversation. So they use the word every time. They use the word over. Okay, so if they say over means the other person will start sending the data. So this is walkie-talkie, and we have some radios available. Okay, that means this is citizens band radios. So these are all examples for off duplex communication. So full duplex, both the station, that means both the sender and the receiver can transmit and receive the data simultaneously. Okay, at the same time, share the capacity of the link. So the transmission media's capacity will be shared by both the end. So both the sender and the receiver are going to share the capacity of the link. So this is divided between the two directions. That means the capacity of the link will be divided into two. So one part will be used for sending the data. The other part will be used for receiving the data. Then the example is a modern mobile communication system, the telephone system. So these are all the examples for full duplex. Okay. So there are three different modes: simplex, half-duplex, and full duplex. So the next topic is introduction to networks. So what do you mean by a network? So network means a set of devices. So we are going to refer it as nodes. So a group of nodes connected by a communication links. So if you take our college, so we have around 300 to 400 computers we have. All the computers are connected. Okay, all the computers, we are going to say nodes. All the nodes are going to be connected by using the cables. So this is called a network. So here the node is going to be a very common word. So node means, it could be a computer, it will be a printer, a scanner, okay, or any device, a router, a switch. So everything it includes. So the node could be anything. So this is going to be capable of sending or receiving the data. So a node could be sending the data or it could be receiving the data. So generated by the other nodes. So what we understand from here means a node can generate the data. That means it can generate the data and send it to the receiver. And also at the same time, it will receive the data from others. Okay, so this is going to be the network. Okay, a proper definition for the network. Then the next very important concept I can say, okay, is a distributed processing. So what is a distributed processing means? In the networking, we use the distributed processing concept. So what exactly a distributed processing means? A task. It could be anything, a task. Okay, a task will be converted into small task. You can say it's a subtask. So the subtask will be divided among all the multiple computers. So instead of giving a single task to a single host, to a single computer, so what we are going to do by using the networking concepts, so we are going to divide the task, okay, the big task, we are going to divide it into smaller subtask. Okay, so for example, you can see it here. So this is a very big task. So I want to complete this particular task, let it be X. So instead of giving the whole task to a single host, okay, so we have networking concept. So what I'm going to do, I'm just going to divide this into smaller things. Okay, so I'm dividing into multiple tasks. Okay, we can say it is a subtask. Then, so each subtask I can give it to a host. So this is for the host number 1 and this is host number 2. Okay, this will be done by completed by host number 3 and host number 4 is going to compute this. So we can divide the subtask among the various devices and we can process it. So finally the output, again we are going to collect it from all the other hosts and we are going to combine it together. So this concept is called a distributed processing concept. So most networks, they use the distributed processing, so in which a task is divided among the multiple computers. Instead of one single large machine being responsible, so this is what I explained now. So instead of a single large machine being responsible for all the aspects of a process, separate computers handle a subset. So I use the word subtask. So you can divide it into subtask. The subtask will be distributed to all the other computers in the network. They can process it. Okay, they are going to do some computations, whatever it is, and finally the output will be collected and it will be composed. So this is called a distributed processing. So distributed processing is possible only because of networking. So if you don't have the networking concept, so distributing, that means the distributed processing is not going to be possible. Then the next topic is types of network architecture. So network architecture, there are two different types. The first type is peer-to-peer, P2P. The second one is a client-server architecture. So this is a very popular architectures available. Now, this is going to be the base. So from this we can develop, there are so many other architectures also available, but this is going to be the base. Okay, so peer-to-peer and client-server architecture. Now, you can see the block diagrams here, or we can see the topology diagram here. So the first topology is a peer-to-peer network. So this is a peer-to-peer network. Okay, and second one is a client server architecture. So in a client server architecture, so you will be having lot of client machine. Okay, we can say it's a host. So this is client machine, and this is a client machine, and this is a client machine, and printer. The printer is also going to be a client machine, client, or we can say it's a host. Now there is a specialized machine called a server. Okay, so there is a specialized machine. So this is called the server. So what the server is going to do, we will discuss it in the coming slides. So a server machine will be available, which is going to be a centralized one, and it is going to control the entire network. The entire network will be controlled by this particular machine server. How it is going to control and all, we can see in the coming slides. So whereas in the peer-to-peer network or peer-to-peer architecture, so we don't have anything like server. There is no centralized control here. Okay, you can see this is a client machine, client machine, client machine. So printer, I'm considering this as a client machine. So client, client. So we don't have a specialized server machine here. So it means, so we don't have any centralized control mechanism here. So there is nobody to control, okay, your network here. So this is the basic difference between a peer-to-peer and a client server architecture. So now let us discuss about both the things. So the first thing, I'm going for the peer-to-peer networking. So we are going to discuss the advantages of peer-to-peer and disadvantages. Client server architecture, we are going to take advantages and disadvantages we are going to discuss. Now, let me go for the first one, peer-to-peer. So peer-to-peer networking advantages. So what are the advantages of peer-to-peer networking? So the first thing is, it is easy to install and configure. So it's very easy to install and configure. So just you need all the host machines, plus you need the transmission media. Okay, that's it. So you are going to easily install and configure things. So here we don't have any dedicated servers. Okay, I use the word. There is no centralized control in this. So no dedicated servers will be available. So user control their own shared resources. So who is going to control means the users, individual users, they are going to control. So every host, they are going to have their own control. So they can decide what they want to do. So individual machines having the full control here. So they can decide, okay, what exactly that machine wants to do. So it is a very inexpensive method, okay, to operate and also for purchase. So you no need to spend too much of money here. So because there is no dedicated server, only ordinary host machines plus cables, transmission media is available. So that is enough. You can create a peer-to-peer network. So no dedicated administrators are needed, okay, to run this network. So this network, we no need to have an administrator, no specialized technicians, so nobody. So easily you can run this machine, and works best for the networks with 10 or fewer users. So if your network size, okay, if your network size is less than 10, then you can go for a peer-to-peer networking. So peer-to-peer is it's very cheap economically, okay. So it's cheap, okay, and also it's very easy to install and configure. Now I'm going for the next topic. The next one is the disadvantages. So disadvantages of peer-to-peer networking. So almost all the points we already covered, we can see. So this is security. Network security applies only on a single resource at a time. So security is going to be an issue, okay, because there is no centralized control here. Individual machines can decide anything. Individual machines can fix their own role, okay. So automatically what is happening means in individual machines you need security. So there is no centralized control of security here. So this is one of the drawback. Then many passwords are to be shared. Many passwords are their shared resources. So the same thing, passwords also is going to be different. Every machine is going to have a different password. Okay, so it's going to be very difficult to share. Then individual backup to protect all the shared data. In every machine, we have to do the backup because the data is scattered. Okay, the data is scattered everywhere in the network. So there is no centralized control. So in individual machines, the data is available. So you have to take the backup of the individual machines. So this is going to be a time-consuming process, and also it needs more memory. Okay, that means the resource, you need more resource. Then performance of the machine reduced every time the user access. So whenever the user access, automatically the performance is going to be reduced. Then no centralized to control access data. So this already we have discussed. So here there is no centralized mechanism. Okay, so because of that, access control is going to be a very difficult one. Okay, so this is mostly everything will be related with the security. Okay, security issues will be more here. Then does not usually work well with more than 10 users. So if the number of users are more, if it is more than 10, just for an example we are taking, if it is more than 10, automatically, so peer-to-peer networking is not going to work well. Okay, so you have to go for the next architecture, which is the client-server architecture. Now, the next, the second type of architecture we are going to discuss is client-server. So client-server networking. So we are going to discuss what is advantage and disadvantage. So before getting into this, the text, the slide, you must understand. So there is a centralized machine here. So the centralized machine is going to control everything. Okay, so we need some administrators here. Network administrators should be available. All your data will be stored in this machine. That means in the server machine. So these are all the logical things you must understand. Now we can see the advantages now. So a centralized user accounts. So in our college, so we are doing this. So if you want to log in into a machine, you need a username and password. So without username and password, okay, you cannot enter. Okay, you cannot use a machine. So the username and password, where it will be stored means it is stored in the centralized server. So the authentication will be done. So once if it is authenticated, you are allowed to enter into the machines. So access control is available. Okay, we have a very good access control system, and also the security is available here. Now, if you see the machine, the server machine is going to be a very robust. It should be a very strong machine. A very strong machine. Okay, if you compare the server machine and the host machine, the server machine is going to be like well configured machine. Okay, the hardware configuration should be very high. Okay, in terms of memory, in terms of that means the RAM, okay, processor, hard disk. So in terms of all these things, okay, the machine should be very strong. Okay, so server hardware is more robust with fault tolerant and redundant system. So fault tolerant, so to manage the errors, to manage the faults, and the redundant system means the backup system should be available. Okay, for a server, definitely there should be a backup already. Okay, because always, suppose if there is any crash, okay, if the server is not working means your network will be down. Nobody can enter into the network. So in that case, definitely you need a backup. Yeah, alternative server should be available. So a single password for a network login delivers access. So this is a very important one. You can go to any lab. Okay, lab number 104, 105, 106. You can go to any lab. You can sit in any machine. You can use the same username and password. Okay, so the username and password is not going to change. So anywhere you can use the same username and password. You can log in into the machine and you can use the machines. So this is makes sense for a network with more than 10. So 10 or more users if you have in your network. So go for the client server network. Then the next one is the disadvantages. So disadvantages means, okay, the very important thing is the cost, because the server machine is going to be expensive one. Then the second disadvantages here is you need some specialized or a trained people to manage your network. So everybody cannot manage. Okay, so a network administrator should be available. So you should be properly trained in the server. Okay, how to handle the servers. So a specialized people should be available. So these are the disadvantages. Now you can see the points here. A server failure renders the network unusable. Suppose if a server machine is failed. Okay, so generally we used to say single point of failure. If the single machine, that means the server machine is failed, finished, the entire network is going to be down. Okay, this is a major disadvantage. Then it needs expert staff to manage the servers. So we need a specialized people. So those who can manage or those who can handle the servers. So they have to be there. So this is going to increase the cost. Okay, the cost, that means the expenditure. So dedicated hardware and software add to the cost of the client server network. So this also I already explained to you. So the server machine, it's a dedicated machine. So the dedicated machine is going to be expensive one. So two different architectures we discussed: peer-to-peer advantages and disadvantages, client server advantages and disadvantages we discussed in these slides. So the next topic is categories of networks. So basically there are three different categories of networks available. So the first category is called local area network. The second one is a wide area network. The third category is metropolitan area network. So how we are categorizing this means based on the distance, or we can say based on the coverage area. Okay, for example, if you take a local area network, so this will extend only for few kilometers. Okay, only for few kilometers it will be extended. So if you see the metropolitan area networks, MAN, so this could cover a city or a town. Okay, a city or a town. Okay, it will cover. So a wide area network means, okay, it's going to be a global network from anywhere to anywhere. Okay, so there is no limit here. So that means from any geographical location to any other, okay, any place in the world. So this is going to be a wide area network. Okay, so based on the distance, okay, the distance of coverage, we are dividing into three: local area network, wide area network, and metropolitan area network. So let us see one by one. Local area network. So local area network means, so this is a privately owned. Okay, for example, you take our college. Our college is having a local area network. So this could be accessed only within our college. So within that building, okay, or within the campus. So you cannot access the local area network, okay, from your home. So it's going to be in a very small place, okay. So within a building or within a campus. So this is going to be a local area network. So limited to few kilometers, maybe some 3 or 4 kilometers maximum you can extend. So you cannot extend more than that. Then, so this is designed to allow the resources to be shared between the resources, between the host. So all the resources you can share here, okay, between the host. Then the second category is metropolitan area network. A metropolitan area network, okay, here you can see this is the size between the land and WAN. Okay, this is a local area network, few kilometers. Wide area network, there is no limit. So between the local area network and WAN wide area network, so we have the metropolitan area network. So it is a network with a size between a LAN and a WAN. So it is normally cover the area inside a town or a city. So entire city or entire a town or a city, it will cover. So wide area network. So it's a long distance transmission of data. Okay, long distance. Long distance means how long, how far it is. So it could be from any place to any place. Okay, you can take from Oman to UAE, or Oman to India, or Oman to USA, so any place. So normally created and run by the communication companies. So internet service providers. So it will be run by the internet service providers. Examples of WAN, it is a point-to-point WAN, switched WAN. So these are all we are going to cover in our coming lectures. Okay. So based on the distance, or we can say based on the coverage distance, or based on the location, we can say. So we can divide into three categories. Okay, the networks we can divide into three categories. So the first category is a LAN, second category is a WAN, wide area network, and the third category is a metropolitan area network. Now, the next one is Internetwork. So what do you mean by an Internetwork? So Internetwork means, so very simply we can say, it's a collection of networks. Okay, so from one network to another network, you are going to send the data, or you are going to connect two different networks, three networks you are going to connect. Okay, for example, you can see this topology diagram. So this is, okay, a local area network, a LAN, and this is a local area network. So we have lot of local area networks here. Okay, so these are all the local area networks. Now, all the local area networks I'm going to connect by using a device. So the name of the device is called the router. Okay, so router is a device. So you may not understand what is router now. Okay, so we are going to cover in this course, okay, networking devices. So you will understand it later, but it is a networking device. Okay, router. So by using the router, if you want to connect two different networks, you need, okay, router. Without router, you cannot connect. So router is a device. Okay, so all R stands for routers. So now I'm connecting, this is one local area network, and this is the another local area network. So two local area networks I'm connecting by using the device router. So if I connect all the networks, all the local area networks like this, so that is going to be the Internetwork, or we can say it is a wide area network. So this is the internet. So what do you mean by internet means, you see, two or more networks are connected, so make an Internetwork, or we can say it is a internet. So this is the entire networking, internet concept. So internet is going to be a collection of networks. Okay, collection of networks. So this is about the internetworking concept. The next topic is switched networks. A fully switched network is a computer network which uses only network switches rather than Ethernet hubs on Ethernet networks. So it will be completely having only the switches. Now, switching. So what is exactly a switching means? Forwarding the packets or sending the packets from one port to the another port. So that is going to be the switching concept. So we will discuss about this switching concept in the coming lectures of this course. But we are going to give a small introduction for what is a circuit switch networks and what is a packet switch networks. Okay, just a small introduction we are going to see here. Internet is a switch network in which connects at least two links together. So it's going to connect two different links. So what is two different links means? So X is a machine and Y is a machine. So these two will be connected by using some devices. So a switch needs to forward the data from one port to another whenever required or whenever it is required. So the data is going to become, we'll see in the next slide. Okay, so this is going to be a device, a switch device. So the data will be arriving in one port. So we have to forward it. Okay, we have to move it to the next port. So this process is called the switching process. So there are two different types of switching available. The first one is the circuit switch network and second one is the packet switch network. In a circuit switch network, you need a dedicated connection. Okay, so that will be a dedicated connection. So we can call the connection as a circuit. So and this will be always available. Okay, it will be always available between the end-to-end systems. Example, your telephone network. So that means the landline telephone that we use. So in a landline telephone, so definitely there should be a cable. So connecting you and the provider. So it's a dedicated connection will be available. But whereas in a packet switch network, we don't have any dedicated connection will be available. So the communication between the two end system is done in blocks of data called packets. So we are going to use the packet concepts here. So using the packets, the data will be moving. So packet switch networks are more efficient. So it's going to be very efficient than the circuit switch network. So we can see the difference. What is the difference between the circuit switch network and packet switch network and how it works? Okay, we can see it in the coming slides. Now, we can see the difference here. Circuit switching, packet switching differences. So in a circuit switching, so we need a physical path between the source and the destination. So between any source and a destination. So that should be a fixed physical path will be available. But here there is no physical path in a packet switching network. All the packets uses the same path. So any number of packets you can send from a source to a destination. So all the packets, it is going to follow the same path. But here the packets are going to move independently. So it is not necessary that all the packets will travel in the same path. Okay, so it can move in any direction. Then reserve the entire bandwidth in advance. So in the circuit switch, all the bandwidth, that means the entire bandwidth of your transmission media will be reserved in advance, but here does not reserve. So here waste of bandwidth. So bandwidth wastage will be available. So here there is no bandwidth wastage, and here we are not having any store and forward transmission. So what exactly the store and forward means? So the latest switches are store and forward devices. Okay, what is it? The store and forward means you can receive the entire frame. Okay, so you may not understand some technical terms. Okay, because this is lecture number 1. So once if you watch all the videos, so then you can understand what is the store and forward, what is a frame, what is a packet, everything you will understand it later. So here there is no store and forward transmission, but the packet switching is going to support store and forward transmission. So these are the differences between the circuit switching and packet switching. So we can see an example in the coming slides. You can see the circuit switch. This is the source machine. So I want to send a data from here. Okay, this is the source and this is going to be the destination. I want to send some data from the source to the destination. I'm going to use circuit switching concept. By using the circuit switching concept, you can see the path is a dedicated connection. So all the packets, okay, all the packets are going to use the same path, okay, to reach the destination. Actually, I should not use the word packet. but I'm using, okay, the packet now. It should be frames. You will understand it. Everything will be clear once if you go for lecture number 3, 4, okay, like that. Now, so a dedicated connection is available from the source to the destination. From X to Y, there is a dedicated connection is available here. So all the packets are going to follow the same path to reach the destination. Now, if you go for the packet switching, so we are going to use the packets here. You can see the packets 1, 2, 3, 4. Okay, these are all the packets. So by using the packets, we are going to send the data. And here, so my source, this is my source. So I want to reach the destination. This is my destination. So here, there is no fixed path available here. You can see. So few packets, okay, packet number 1 and 2, it is now traveling in a different way. 3 and 4 is traveling in a different path. So finally, it is reaching the destination. Okay, so there are two different paths they are selecting. So this is the path number 1 and this is the path number 2. So these are the two different paths it is selected here. So this is the packet switching. So packet switching is having a lot of advantages comparing with the circuit switches. So this is about a small introduction, but we are going to cover this in the coming lectures. Now, so internet today, the next topic, internet today. So internet today is an internetwork that allows any user to become a part of it. So anybody can join in this network. So even if you have a mobile phone, you can easily you can join the internet network. That means in the internet. So it's a global network. Internet is a global network. It's a collection of many networks. So we already discussed this point in the previous slides. Then accessing the internet. So there are different methods available to access to the internet. There are plenty of methods. So by using your mobile phone, you can connect it. By using your Wi-Fi, okay, you can connect. So there are different methods available. So we can see what are the different methods available means. So by using the telephone networks. So this is very popular. Everybody is having, okay, a telephone connection, and we have some modems, okay, ADSL modem or DSL modem. You can use a modem and you can access to the internet. So you can have a dial-up service. Dial-up service is an old one. So nowadays we have the DSL, okay, digital subscriber link. So DSL, ADSL also available, okay, or you can have the optic fiber also we can have. So the second method is the cable networks. So by using the cable, that means the coaxial cables, so which is provided in our home, okay, for connecting with the TV. So by using the cable also, we can have cable networks also, we can have the internet connections. Then wireless networks. So various wireless networks like Wi-Fi, cellular, satellite. So these are all the different ways available to connect it to the internet. Then, so you can have a direct connections to the internet, such as the leased lines, okay, high speed wide area networks. So this is from the internet service providers directly you can connect. So if you want to connect a host, okay, if you want to connect a machine, okay, it could be anything. The host means it could be anything, your laptop or your device, any device, okay, including mobile phone. So if you want to connect, so there are different methods available. So these are all the different methods how to connect it with the internet. So the next topic is network criteria. So if you take data communication and network, okay, so there are three important things. The first one is the performance, network performance, network reliability, and network security. So these are the three important criteria, okay, for a network. So a network, you have to measure the performance of the network, the reliability of the network, and the security of the network. So about these three, we are going to discuss in the coming slides. Performance. So the performance of a network, you can decide by using two things. So first thing is a transit time. Okay, so transit time, and by using the response time. So by using these two time, okay, or two variables, we can say let it be T1, T2. So by using these two variables, you can, okay, you can decide or you can evaluate the performance of a network. Okay, so what is transit time? Means the amount of time required for a message to travel from one device to another device. Okay, from one device to another device. Okay, if you take X is a device and Y is a device, so the amount of time required for a message to travel from here to here. So this is going to be a transit time. So what is a response time means? Is the elapsed time between an inquiry and a response. So that means I'm going to send a request, okay, a request. So from there, I'm going to get a reply. So the time taken for this. So this is going to be the response time. So here it is one way. So I'm going to say this is T1 and here this is, okay, T2. So this T1 and T2, it is going to say the performance of your network. Suppose if T1 is taking too much of time and T2 is taking too much of time, means automatically your network performance is not good. So the T1 value, T1 should be, T1 and T2 should be less. So if it is T1 and T2 are less, then we are going to say your network performance is good. If it takes more, means automatically the network performance is not good. Now, T1 and T2, it is going to depend on all these factors. So there are so many factors which is going to affect this T1 and T2, time 1 and time 2. So what are the factors means? You can say the number of users. So whenever the number of users increase, so automatically the performance will be affected. The types of transmission media. So the types of transmission media, it's a cable, the types of cable you are using. Suppose if you are using an Ethernet cable, if you are using, okay, fiber optic cables. So depending upon the cable, wireless media. So depending upon the cable, the performance is going to change. Then capability of connected hardware. So connected hardware means the hardware that you use, the devices that you use. Okay, for example, the switches, what type of switches you are using, what type of routers you are using. So these are all the hardware, that means the networking hardware that we use, and also the software that we use, networking software that we use. So depending upon all the four, okay, the performance of a network will be affected based on the number of users, types of transmission media, the hardware and the software that you use. Then there are two words available here. One is the throughput and delay. So we are not going to discuss these variables here. These terms here, throughput and delay. We will discuss it, okay, in the coming lectures. It's a very important one. So the two important network metrics, one is the throughput and second one is the delay. Okay, we will discuss it in the coming lectures. Then, so this is the first criteria, performance. The second criteria is reliability. So the network reliability can be measured by using few things. So what are they means? Frequency of failure. So if your network is completely, okay, keep on, okay, it's failed, there are some errors you are getting. So the frequency of the failure. So for past 1 month, my network is, okay, it's working fine. I don't have any failure in my network. So it keep on going for more than a month means then your network is more reliable. So every day I'm facing some problem in my network. My network is down. Almost every day it is, okay, it's down because of some reason. So automatically your network is not reliable. So the frequency of failures is going to decide the reliability. Then the time it takes a link to recover from the failure. Suppose some failure happened, some X thing, some X it's happened. So how much of time it takes to come over, okay, from that particular failure. So this is also going to be the designing the reliability of your network. Then network's robustness is a catastrophe. So the network robustness, that means how strong your network, it's really is going to be a problematic one. It's a catastrophic one. So we have to make our network, okay, a very strong one, more robust, more reliable. Then security. So it's a very big concept, security. Okay, so that means it is going to talk about the three things: CIA, confidentiality, integrity, and availability. So your network should be confidential and it should have integrity. Okay, then it should have availability. So the three things you must have in your network. So that is security concepts. So network security issues include protecting the data from the unauthorized users or unauthorized access. So this is what I mean confidentiality. Protecting the data from damage and development, implementing the policy and procedures. So this is another part of security. That means security management. So you need a proper policy, security policy for your organization. So you have to implement that particular policy and procedures, okay, and you have to follow it properly. So implementing the policy and procedures for recovering from the attacks, data loss. So the main thing you have to keep it in your mind, that is CIA, confidentiality, integrity, and availability should be ensured. Okay, so that is the principle, the main aim of security is this. Now, so the next one in this lecture, the next topic is standards. So standards. So what do you mean by a standards? Means a standards is going to define something to us. Okay, something X, Y, Z is going to define properly something to us, and we have to follow that. Okay, everybody should follow that particular standards. So standards are essential in creating and maintaining an open and competitive market for the equipment manufacturers and in the guaranteeing the national and international interoperability of data and telecommunication technology and process. Very simple. I'll just go for a very simple thing. I'm going to manufacture a keyboard. Okay, I'm going to start a company, okay, to manufacture the keyboards, okay, the input device. So while manufacturing a keyboard, I have to follow certain standards. Okay, for example, so the very popular standard is QWERT. So this is the standard so that everybody follows. Okay, you can see in your keyboard. So if you see the keyboard on the right, that means the top top left. Okay, if you see, you will find, okay, the keys will be arranged like this: QWERT. So then next to that it will be like ASDF. So I have to follow this particular standard. So when manufacturing a keyboard, I have to follow this standard. If I am not following this, means my product will not be accepted, okay, globally. So you cannot make anything by yourself. Okay, for example, I'm going to start a transmission media UTP cable. I want to make a UTP cable. I want to produce. So I cannot follow my own instructions, my own set of protocols. I cannot. So there will be some standards. So we have to follow the particular standards. Then only your product will be accepted globally. Okay, so then only your product will be accepted by anybody in the world. Okay, so this is standards. So for everything, the standards are available. So standards provides guidelines to the manufacturers, to the vendors, to the government agencies and other service providers to ensure the kind of interconnectivity necessary in the today's marketplace and in the international communications. So whatever it comes, okay, any software if you want to develop, okay, any protocol you want to develop, okay, or any hardware devices you want to produce, so you have to follow certain standards. Okay, so without standards, you should not do anything. Now, these standards we can divide into two. So the first one is called de facto standard, and second one is de jure standards. So what is a de facto standard means? The standards that have been approved by an organized body, but have been adopted as standards through widespread use or a de facto standards. So this is going to be the fact, based on the fact. So some organizations, they will fix it. Okay, they will fix some standards for that. So if you are manufacturing that particular product or if you are developing a software, you have to go for that. So de facto standards are often established originally by the manufacturers who seek to define the functionality of the new product or the technology. So any product you can develop, you have to go for the standards. So it's already fixed by some organizations. So there are a lot of standards organizations available. We are going to see in the coming slides. So the next one is a de jure. So these standards have been legalized. Okay, it should be like legislated by an official by an officially or a recognized body of de jure standards. Okay, this may change from one country to another country sometimes. Okay, which is created by law. Okay, but whereas a de facto means is going to be like international, everybody will be accepted. So there will be slight adjustment available in the de jure concepts, but in the de facto, everybody will accept, everybody should follow globally. Okay, international wide, everybody will follow the same. Now you can see the internet standard. So if you take internet standard, an internet standard is thoroughly tested specification. It will be already tested by someone. An internet draft is a working document. So sometimes you may get a document like RFC. So it's a working document with no official status and 6-month lifetime. And a draft may be published. Okay, so it's very popularly called request for comment, RFC. So you can just Google it. Okay, if you just Google RFC, you will get a lot of RFCs with numbers. Okay, so for every protocol there will be an RFC, request for comment, will be available. Then, so you can see the standards organization in the next slide. So there is a very big list available, but we are just going to take only 5 standard organization, but this is not the complete list. Okay, if you just Google it, standard organizations for networking, okay, or information technology, so you will get a lot of organizations. So only 5 things we are taking here. So the first one is a International Organization for Standardization, ISO. So this is a very popular standard organization. Okay, then the next one, ITUT, International Telecommunication Union Telecommunication, ANSI, American National Standards Institute, IEEE, Institute of Electrical and Electronics Engineers, EIA, Electronic Industries Association. So I'm not explaining what is the purpose, okay, or what is the role of each and every organization. We are not discussing here. So just we are seeing only the names, okay, the names of the standard organizations: ISO, ITUT, ANSI, IEEE, and EIA. So with this, we are completing lecture number 1. So we can see the summary. So what we discussed. So we discussed what is data communication, what is a network. Then we discussed about the components, the 5 different components of communication system, okay, like message, sender, receiver, medium, and protocol. Then different types of data. What are the different types of data we can send in a network? So text, numbers, images, audio, video. Then we discussed about the data flow, the 3 different types of data flow, that is the simplex, half-duplex, and full duplex. So then we discussed about what is a network. Then we discussed about the distributed processing. Okay, so then the protocols. So finally, we discussed about the standards. Okay, what are all the different standards available? Okay, in between, we discussed about the categories of networks, the 2 different categories we discussed, 2 different architectures we discussed. Okay, so finally, we discussed about the standards organization. So with this, we are completing lecture number 1. Thank you.